would like to thank you for being here, to welcome you. We learn from each other, and we learn also from audience like you. So this interaction for us is very important because we get feedback from our work, and we try to incorporate that and improve our work.
To be that we are initially using some existing technologies, so we are all witnessing this kind of AI revolution that's going on, and indeed there are many valuable models, AI models, that do the things that we aim for. Actually, I will specifically focus on use case 1, as we call it, which is like browsing the archives. And you also want to have some augmented experiences, and I will talk about only the audio, for example. Or you want to search for specific content regarding the video, so for example for the audio. So imagine, for example, you want to find a theatrical play or a dance performance that has, for example, fast-paced music, or some performance or some theatrical play that it resolves in a happy end. You listen to someone speaking, but it happens that it's not the language that you're speaking, so you want to have some kind of a translation. We are trying to somehow get this semantic information from the audio. So we are tracking voice, speech, we're tracking music, we're also tracking some other events that might happen, and we try to make some sense out of it. This is the very broad overview of what we are doing.
We are analyzing the image and video without audio, and the idea is the same, so to extract a lot of semantic information, so some important information about what we can see here. So the bounding box you have seen in the video, we are extracting this. We just download the video and automatically extracts the people there, tracking them, so we have a number for each box, and we are able to say how much time they are in this video and how they move and so on. We can also extract the depth information, so these are false color. The red is very close for the camera, and black blue is very far from the camera, so we are automatically extracting this. We can also extract a 3D body. So as you can see here, we just match one mesh, 3D mesh, which is stored somewhere, and we try to match to each people in every image.
And we are working on specifically 2 use cases with extended reality technologies, and more specifically with VR technologies. The objective there is to have the performance and see how can we broadcast and stream that performance in a virtual reality space for people to view it outside of the theater. The technical challenge is to be able to capture data from a live performance and use this data within a virtual space. We call it the remote rehearsal use case, and the idea is that we can have 2 performers from 2 different remote locations. The idea is that they meet and collaborate in a joint virtual space.
The 2 models I will be showing, they are models that produce movement. And the first model, the thing that you see now, is what I call a movement transformation model, or this application, where you can combine different types of movement recordings and blend between them. So Pablo is working heavily on sonifying movements, translating movement into sound, and I'm working on translating movement into image. And we are both not interested in creating like realistic avatars, replicating the appearance of existing dancers or actors, but we are more interested in coming up with something that looks very different.